There's the train. I don't know if you can hear it. Yep, so we're in section 5.2, which is continuing with probability distributions, discrete probability distributions. We want to focus on the mean and the variance of a discrete random variable. So remember what a discrete random variable is. It's some type of characteristic that takes on values that are whole numbers. And what values it takes on is determined by chance. So what is the mean? The mean of a discrete random variable? It's the value we should expect to get based on probability weights of a probability distribution. So the mean is what we should expect to get based on the probability weights of a probability distribution. So sometimes we call the mean the expectation or the expected value. So sometimes you hear it called the expectation, or also the expected value is another word that you hear, expected value. So the symbol that we use for the mean for a random variable is this Greek letter mu. Looks like a funny looking M. Greek letter mu, and that's the mean. I'll write that to the side. Mu means the mean. That's equal to what you do. You take your data values, x, times your p of x's. Those are your probabilities in the probability distribution. And you add those up. So the summation symbol, that means add up there. So again, x, those are the data values. P of x, those are the associated probabilities and the probability distribution, or the probability weights. And this symbol, that backwards looking, almost looks like a backwards E. This is the add up, right? It means to add up. So we're going to do, you're going to multiply the data values, the x values, or the values, let me say the values of the random variable. So just the values of the random variable times the probability weight. So you take the values times the probability weights, and then you add those products all up. Okay. I will do an example later. We want to introduce also the variance. We talked about mean already when we did statistics, and now we're doing probability, talking about the mean. Now we're going to talk about variance. So variance in the context of probability. The variance. What is the variance of a discrete random variable? The variance of a discrete random variable is the expected square distance, between the random variable x and the mean. The larger the variance, the more spread out you should expect your values of x to be. Yeah. So here's the formula we use for variance. So we use this symbol here. This is the lowercase Greek letter sigma. That's lowercase Greek sigma. I put a little square on that for the variance. So this is the formula for the variance. Now this is sigma squared means the variance. This is for a random variable, x. What you do, you take your x squared times p of x, Remember what x is. X represents the values of the random variable. So you're going to square your values of your random variable, and then you're going to multiply that by p of x. Then you're going to add all that up. So let's see, x is equal to the values of the random variable. P of x represents the probability weights that correspond to the values in the probability distribution. And this symbol means add up, right? If I can spell add up. I'm not done with my formula. Then you have to subtract, after you calculate that thing added up, then you have to subtract the mean squared. The mean, so mu is the mean that you found in the previous problem, from the previous formula. So that's the formula for the variance. So also you have the standard deviation. What about the standard deviation? The standard deviation. This is just the square root of the variance is the root of the variance. And it turns out that the standard deviation, you just use the lowercase sigma for that. So that's going to be the square root of the variance, sigma squared. So this symbol here, lowercase sigma, that's the standard deviation. And like the variance, it measures how spread out you should expect your values of x to be. The thing is that the variance is measured in terms of square units. The standard deviation is just measured in ordinary units. That's the big difference. Okay, so we want to use these formulas. The mean, the variance, the standard deviation. I have some problems here. Here's an exercise. Consider the discrete probability distribution below. Okay, I'm going to draw a table. So first of all, I'm going to tell you what x represents. X is a random variable. It represents the number of boys. Number of boys. If you have 3 children. So let's say you have 3 children. Oops. Shouldn't be doing that. I don't know why it does that. So let's say you have 3 children, and x represents the number of boys that you can have. You could have no boys, 1 boy, 2 boys, or 3 boys, right? That's the maximum number of boys you can have if you have 3 children. 0, 1, 2, or 3. And here P of x tells you the probability of this happening. So the probability of having just 0 boys is 1/8. So notice here we're written as fractions. That's okay. Most of the time I want you to deal in decimals. Your probability is in decimals. But it's okay when you're doing these discrete probability distributions to have them as fractions. Sometimes it's actually useful to deal with fractions. Easier to deal with fractions than decimals, surprisingly. Because with decimals, sometimes you get some really bad round off here. Fractions sometimes can be more accurate. Okay, so here's our probability distribution. So you have a 1/8 chance, a 1 in 8 chance of getting 0 boys if you have 3 kids. You have a 3/8 chance of getting just 1 boy. You have a 3/8 chance of getting just 2 boys. And you have a 1/8 chance of all 3 of the children being boys if you were to have 3 children. So the first question is, part A. Determine the mean number of boys. Mu. Okay, so what would the average number of boys, or the expected number of boys? Another word for the mean is the expected value. Expected number of boys, or the mean number of boys. So we're going to use the formula. Mu, it's the mean, equals, you take x times p of x, and then you add those up. So what I'm going to do, I'm going to create a red column here on the side. I'm going to name it x times p of x. So what we're going to do, we're going to multiply our values together with the corresponding probabilities. So I don't know if you know how to really multiply numbers times fractions. You take this guy, 0 times 1. 0 times 1 is 0, and that's going to be 0 over 8. You just put it over the denominator 8. And then I'm going to take 1 times 3. It's going to give me 3. And then over the denominator 8. And then I'm going to take 2 times 3. 2 times 3 is 6. That's going to give me 6 over top of the denominator 8. Now I'm going to take 3 times 1. 3 times 1 is 3. That's over the denominator 8. So what we have to do now, we have to add these up. Add these up. I'll put a little summation thing here. Summation. So do you know how to add fractions is the question. So what you do, you keep the common denominator. So notice how the denominator is 8. So I'm going to make a big fraction bar with an 8. And you're going to take all the tops and add them up. So you're going to have 0 plus 3 plus 6 plus 3. So you just add up the tops over top of the... You have to have a common denominator in order to do it that way. We already have one of 8, right? So when I add these up, let's see. 0 plus 3 plus 6 plus 3, let's see, that's 9. 12, right? 12 over 8. And if you take 12 and you divide it by 8, you're going to get 1.5. So that means, yeah, so this was 12 right here over 8. Right, we added up those top numbers, 0 plus 3 plus 6 plus 3 is 12, over the denominator of 8. In any case, I'm going to write down here, 12 divided by 8 is 1.5. Well, that's my mean number of boys. So I should expect to have 1.5 boys. Now, I know you can't actually have half of a boy, right? You really can't have half of a boy. This is just, you could say, an approximation. Not really an approximation, but I mean, the way to think about it, here's the way to think about it. If I were to draw this as a graph, where I put my probabilities on the vertical axis, right? And my number of boys here on my horizontal axis, I could have 0 boys, 1 boy, 2 boy, or 3 boys. And for my probabilities, you could have like 0 here. This would be like 1/8, 2/8, 3/8, and let's just do a little graph here. So going back to the original distribution right here, probability of having 0 boys is 1/8. So we could draw a graph like that. The probability of having 1 boy is 3/8. The probability of having 2 boys is 3/8. And the probability of having 3 boys is 1/8. Okay, so this gives you a picture of how the probabilities are distributed over top of 0, 1, 2, and 3. If you think about it, so imagine this right here being like a little scale, right? This is a scale, and you have these blue weights on the scale. What you have to do you'd have to hold the scale right here in the middle at 1.5, right? 1.5 is kind of the middle to make sure that the scale is balanced. That green scale is balanced right there. So this is your mean. This is your mean right here. The mean is 1.5. Yeah. So you have to balance it right there at that point so it doesn't tip to the left or tip to the right. That's kind of the idea behind the mean. Yeah. Anyway, that's just an illustration. You don't have to do that. You don't have to draw that picture. Oops. I lost some stuff, didn't I? It's going all over the place. Try to get that back. There it goes. There was a black line there. Okay, there it goes. Okay, so 1.5 is the mean. End of story. Okay, let's do a part B. Part B, let's erase this actually. Part B, what do we want to do for part B? Determine the standard deviation. For the number of boys. That's called lowercase sigma, the standard deviation. Okay, so your formula, before you find your standard deviation, first you want to find your variance. You want to find sigma squared first. And what you're going to do, you're going to take the data values, or the values, x squared. Okay, you're going to square your data values, or your values. After you square them, multiply by p of x. Then add those up, and then subtract the mean squared. So first things first, we have to do x squared. We have to create an x squared column. So I'm going to create a column called x squared. So what is x squared exactly? X squared consists of the first column right here. I'm putting a green dot over top of that. That first column squared. So we're going to take each number and square it. We're going to start with the number. Ooh, why did that go away? I don't know. We're going to take the number 0 and we're going to square that. 0 squared is 0. We're going to take the number 1 and square that. 1 squared is 1. We're going to take the number 2 and square that. We're going to get 4. We're going to take the number 3 and square that. We're going to get 9. So that's the x squared column. Then after that, I have to multiply x squared by p of x. We're going to multiply these together, x squared times p of x. So we're going to take x squared times p of x. So basically what I'm doing here, I'm taking my green column, my x squared column, times this baby blue column right here, right? We're taking x squared times p of x. Let me go back to that orangish color. Okay, that orangish peachish color. We're multiplying these two together, right? X squared times p of x. So the green column with the p of x. So we're going to take 0 times 1 is 0 over 8. So we get 0 over 8. I'm going to take 1 times 3/8. So I'm going to take 1 times 3 here on top. I'm going to get 3 over 8. I'm going to take 4 times 3/8. So I'm going to take 4 times the 3 here on top, which is 12. That's going to be over the denominator of 8. And I'm going to take 9 times 1/8. 9 times 1/8. So 9 times 1 right here is 9 over 8. And remember that your formula says that you have to add all this up, right? You got the summation symbol right here. So I'm going to add this up down here. So imagine, okay, here's my summation out front. I'm going to add those up. So I'm going to take 0 over 8 plus 3 over 8, plus 12 over 8, plus 9 over 8. So these are all over 8. What color am I going to use here? I'll use this. Okay, so we're going to have sigma squared equals. So what were our x squared times p of x's? 0 over 8, 3 over 8, 12 over 8, and 9 over 8. So let me get that color back. It was 0 over 8 I started with. This is all over 8. Plus 3 over 8, so I'm going to have a 3. Leave the 8 on bottom. 12 over 8, so I'm going to have plus 12 on top. And leave the 8 on bottom, and then plus 9 over 8. So just plus 9. Leave the 8 on bottom. Yeah, so since I have the common denominator here of 8, right, we got 8, 8, 8, 8. We're just keeping that common denominator 8, and we're adding the top numbers, right? 0, 3, 12, and 9. That's what I've done. And then I have to subtract the mean squared. What was the mean? It was 1.5 squared, okay? So we got the variance, sigma squared is. Let's add these numbers up on top here. 0 plus 3 plus 12 plus 9 is, what is that, 24? Yeah, 24. So we got 24 on top, 8 on bottom. Minus 1.5 squared is going to give me 2.25. That means the variance is equal to 24 over 8. That's 24 divided by 8, simply 3, right? We have 3 minus 2.25. So your variance is going to be, I believe, 0.75. Now, that's not our final answer, right? We weren't asked for the variance. We were actually asked for the standard deviation. So we have one more step to find the standard deviation. How do you find the standard deviation once you have the variance? You just take the square root, right, of the variance. The standard deviation is going to be the square root of 0.75. And I don't know how far you want to round that. I'll round that to 3 decimal places. It's 0.866 when I plug that in my calculator. That's it. Okay, so we got the mean, the expected value, and the variance. Yeah. This was 24 over 8, yeah. All right, so let's do another example. And then we'll do something much more fun. Something much more complex. Do I have another example sitting around here? Yeah, here's another example. Here's an exercise. Exercise. Get that brain juice flowing. Consider the discrete probability distribution. Below. Okay, I'm going to have an x and a p of x. So x is my random variable. It takes on discrete values 0, 1, 2, 3, 4, 5. Can't spell 2, can I? There it is, 2, 3, 4, 5. And the probabilities are given to be 0.15, 0.30, 0.25, 0.10, 0.05, and 0.15. So the first thing I'm asked here is to find the mean of x. Determine the mean of x. The mean is called mu. Okay, so if I'm finding the mean of x, I got to use the formula for the mean, right? Mu is equal to, you take the x's times the p of x's, and you sum those up, you add those up. So I'm going to create a column called x times p of x. And I'm going to multiply the x's and the p of x's. 0 times 0.15 is 0. 1 times 0.3 is 0.3. 2 times 0.25 is 0.5. 3 times 0.1 is 0.3. 4 times 0.05 is 0.2. And 5 times 0.15, I believe, is 0.75. Yeah. Okay, so if I'm finding the mean, I just have to add these up here. Let's see, what's that going to be? 0.8, 1.1, 1.3, 2.05, I guess. There you have it. There's your expected value or your mean. All right. Now, part B. Asking for the variance. No, the standard deviation. Determine the standard deviation for x. And they call that lowercase sigma. Motorcycles. All right, so here we go. Standard deviation. So the first thing you got to find is the variance, right? That's lowercase sigma squared. It's the sum of the x squareds times p of x's minus the mean squared. So the first thing I need to do, I need to figure out what x squared is. I'm going to make a column of x squared. So I'm going to square all the x's. I'm going to do 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. Okay? Then I'm going to do a column called x squared times p of x. So what I'm going to do, I'm going to take this green column right here along with this p of x column right here. I'm going to multiply the values. I'm going to take 0.15 times 0 is 0. 0.3 times 1 is 0.3. 0.25 times 4 is 1. 0.1 times 9 is 0.9. 0.05 times 16 is 0.8. And 0.15 times 25 is, let me type that in, 3.75. Okay. So now what I have to do, I have to add these up, right? That's what this is right here. I'm going to have to add these up. So right here, I'm going to put a little box. I'll actually add these up. Calculator time. 0.3 plus 1 plus 0.9 plus 0.8 plus 3.75. 6.75 it looks like. So the variance, sigma squared, is this sum here, 6.75, minus the mean squared. What's the mean? 2.05, we found that earlier. So that means the variance is 6.75 minus, what's 2.05 squared? Looks like it's 4.2025. 4.2025. Now your variance will always be positive. If you ever end up with a negative variance, you know you've done something wrong, because variances are always positive. I mean, it's possible to get a zero variance, but you either get a zero variance or a positive variance, never a negative. For all intents and purposes, our variance will always be positive. So I got a variance of 2.5475. Normally I would round it off, but since this guy terminates, this decimal terminates, I'm just going to write it all the way out. Now, I wasn't actually asked for the variance, right? I was asked for the standard deviation. So let's do that next. Right, first you find the variance, and then you can calculate the standard deviation given the variance. So the standard deviation is called sigma. It's just the square root of the variance. So it's going to be the square root of 2.5475, which we're going to approximate that to, I don't know, maybe 3 decimal places, 1.596. How about that? All right, there's our answer. Yeah, I think we'll just quit while we're here, and